Finally, the last page, page 6 of the worksheet for Calculus Lesson 4.1. Problem 19 asks us to sketch a graph of a function with given properties. It gives a couple of points, and it gives intervals where it's increasing and decreasing. So I created one similar to this. Okay, so I created one where we're going to sketch the graph of a function that has points at 1, 3, and 3, -1. That is increasing. The derivative is positive when x is less than 1 and when x is greater than 3. And that is decreasing. The derivative is negative between 1 and 3. First, I'm going to plot the point at 1, 3, then the point at 3, -1. It's increasing, then it's decreasing, and then it's increasing again. That was pretty simple. Problem number 20 asks us to use a calculator to find any extreme values for a polynomial function. So I created my own polynomial function, 3/4 x to the 4th minus 2/3 x cubed minus 3x squared plus 2x minus 4. The next step to finding extreme values is to find the derivative. The nice thing about this being a polynomial function is that there are no other issues with the domain, so we're not looking for any critical points other than the ones that are going to happen when the derivative is equal to 0. So I set the derivative equal to 0, and I have a cubic function. Don't know how to factor it. So this is where the calculator comes in. Your calculator should have some way to solve a polynomial of the 3rd degree. I did that in my calculator, and I just rounded to the nearest thousandth for my 3 solutions. Next, I plugged each of my 3 solutions into the original function to find out what the output values were for each of them. My calculator actually has a nice way where I can put in the expression and then just swap out the input value. So that's what I did to get these 3 numbers, again rounding to the nearest thousandth. Next, I did a real quick graph of my function. I plotted all 3 of these points, so the 1.6, -6.3, the -1.29, and the -8.064, and the 0.316 and the -3.681. I also plotted the point 0, -4 because that y-intercept was really easy. I also know that this was a 4th order function and that my leading coefficient was positive, so my end behavior goes up and up, and my function decreases, increases, decreases, increases. Again, that being normal behavior for a 4th degree function that has a positive leading coefficient. And now for extreme values. Now again, I'm not looking for points, ordered pairs. I'm looking for the y values, the output values that are extreme values. There is an absolute minimum, right? The function bottoms out and it never gets lower than it does at this point here. So I have an absolute minimum at -8.064. I also have a bottom of another valley. And remember, your relative minima and maximum points happen at bottoms of valleys and tops of hills. So I have a relative minimum at this -6.304, again, just pulling off that y value. I have a hill right here, so I have a relative maximum at the y value of -3.681. Now, I don't truly have an absolute maximum because my end behavior goes up and up forever on both ends. So I'm just kind of adding this note at the bottom that as x approaches -infinity, f of x approaches infinity. and as x approaches infinity, going off to the right, then f of x goes up to infinity as well. That's it for the worksheet for lesson 4.1. The most important thing to take out of this is that when you are looking for relative minimas and maximas, absolute minimums and maximums, biggest thing is you're looking for places where the derivative is equal to 0. You're also looking for other critical values, issues with domains, and looking for whether the function is increasing or decreasing over various intervals, and that's just a matter of determining whether the function or whether the derivative of the function is positive or negative. Finally, there was also the mean value theorem, which basically we were looking for places where the tangent line had a slope that was equal to the average rate of change, the AROC. So we had that AROC formula come into play, and setting that equal to the derivative and solving for the x value of that. That's it for now.